So I know it's 4 p.m. I know there's a lot of people still coming back from break, but I'm hoping that you're gonna hang in there with me as I look to speak to machine learning in the support of trading and trading analytics. Let me give her a sec for mine. Testing. Fine for the stream. Okay. I've actually never entered on a theater stage before, so this is cool. I'm feeling really dramatic with my mic set up and my camera and my entrance, so this is gonna be fun. So my name is Erin Stanton. I run the global analytics coverage team at Virtu Financial, and I've been doing trading analytics for the last 15 years. I remember when we first started and we were super excited when we had an Excel analysis, right? We had a data grid and we're like, we're so fancy. And then we moved on to bar charts, even fancier. Tableau came in about 5 years ago and we had dashboarding, and now we have machine learning. So before I go into my presentation, I am gonna talk some industry terms here, and I know not everyone works in the same field in finance, so I wanna make sure that we're all talking the same language. So there was a gentleman by the name of Andre Perel who wrote a paper back in 1988. Yes, I'm going back that far. 1988, and what he wrote this paper about was basically he looked at his paper portfolio and he compared that to the returns of his actual portfolio, and he saw a difference there. And he couldn't really explain what that difference is. So for a paper portfolio, when you decide to buy or sell a stock, you can put the price down the minute you want. So a portfolio manager sees a really good price in the market for Apple, and they say, okay, put down 1 million shares at that price at this point in time, and let's start capturing the return from this time. That doesn't actually happen in reality for large asset managers. They can't just go into the stock market and say, buy 1 million shares. This isn't like their E-Trade account, right? It takes them time in order to transact, to find sellers in what they're trying to buy. So what happens in the stock market when time progresses? The price changes, right? And so Andre Perel called this concept implementation shortfall. My team, and there's a couple people here supporting me, my team spends a lot of time measuring implementation shortfall and trying to make it as small as possible, trying to bring our paper portfolio as close to our actual portfolio as possible. So the second concept is very straightforward economics, supply and demand. So let's take Taylor Swift concert tickets, right? You have an outsized number of buyers. They're all trying to get a set number of tickets. What happens to the ticket price? Yes, exactly. It goes up. I know there's tickets being sold for $25K, which is, I love T Swift, but that's just insane. So the same thing happens in the stock market. If an asset manager buys stock too quickly, they can actually push the price of the stock. The whole concept is buy low, sell high, right? So if I'm pushing the price of the stock purely by buying too quickly, I'm eating up my return. So my team does what's called transaction cost analysis, and this is really where you're trying to optimize your trading strategy to reduce Andre's implementation shortfall while managing your time risk. Okay, so let's go to our first slide here. So on the left, this is what a historical transaction cost analysis will look like. Without knowing anything, probably one of your takeaways is, holy crap, that's a lot of numbers. So we have metrics, different price benchmarks, different ways to categorize our trade, and ultimately what me and my team are trying to do is take all of these numbers, drill this down into a single piece of feedback. Trade this way to trade better. Not as easy as it's said, right? So over time, in a lot of cases, we'll kind of show something like this and be like, okay, well, if you look at this number, it means this, and if you look at this number, it means this, but our clients are like, no. Make it easy, give me one recommendation. Insert machine learning, right? I can take a lot of inputs and pass it into machine learning, and that's supposed to give me some sort of recommendation. I think, possibly, hopefully. So, like everything in life, we have faced challenges. I'm going to talk through 5 key challenges and then apply it to 2 different case studies of models that we've built. So the first 2 challenges that we've run into go hand in hand. So a lack of trust of the model, a lack of trust of the data, a lack of trust to the person who's actually building the model sometimes, right? We get accused kind of what decision did you make? And then what feels very much like a black box. Lack of data. I'm sure if you've attended any conference, right? We're all here at an ML conference. If you attended any other ML conference, a lot of people spend a lot of time saying, data is my biggest problem. I don't have enough data. I have gaps in my data. My data wasn't stored correctly. I don't understand my data. So lack of data continues to be a big issue. My group is really lucky to have data going back to 2008. But even in that data set, we have gaps. We have clients who've come and entered, so we still have data issues. Lack of skill set. So my team, like I think a lot of teams, a lot of us started in what was called big data or analytics or statistics, right, when that used to be a job. So we've had to transform ourselves into now what looks like machine learning practitioners. This takes time. You have to have time to experiment. You have to have time to fail. I think one of the best ways to learn in machine learning is to build a model that's absolute crap, that does absolutely nothing. I've built several of those and learned a lot from it. So, and then you also need time to speak to others in the field, right? Coming to conferences, speaking to others that are doing something similar to share ideas and to gather information. The last one seems like a solvable problem, right? Lack of access to required technical resources. So at Virtu, we are 99% on-prem. So all of those vendors in the lobby who are selling their wares, I am not a buyer of them. We are basically 100% on-prem. So if I need an environment for a really big model that I'm trying to train, I have to spin that up internally. And that takes time and resource. Okay, so how have we tried to tackle all of these challenges? First off, I think is what is really important is how we approach machine learning. And this is not how we started. This is how we currently approach it. It's really important to start with a small, well-defined goal. I think a lot of people, myself included, you try to build that Swiss Army knife type model, right? It can do everything. We've had no success with that type of model. So what we instead focus on are very small, well-contained problems that we're trying to solve with machine learning. We also loop in our stakeholders early and consistently. I'm sure other people have mentioned this, right? I hear this all the time. Oh, I loop people in as early as possible. We try to talk to our end consumers who are traders on the asset management side. We try to talk to them even before we've started building a model. Hey, we're thinking about building this model. What do you think? Any gotchas? What's your intuition? We want them to feel like they're at the table early on. The other thing that we do to especially combat that lack of trust and black box feeling is we try to be 100% transparent. So we are not Google, right? We are not Netflix. I'm not having these models that I will never talk about. I'm selling my models to end consumers. So for every model that I'm willing to publish, that I'm willing to put out into the ecosystem, I've committed to providing transparency on the following 3 items. I will tell you that the data that I included in the model, but more importantly, the data I wish I had, right? That's always something I feel like we don't talk about a lot in ML. We're like, we had a year worth of data, but in the back of your head, you're like, it would have been a lot better if I had an extra year, or it would have been better if I had Asia included. This is supposed to be a global model, and I only have Europe and the US. So we will always publish the data we included and the data we wish we had. We will also publish the specific features that go into our model, as well as the features that we actively decided to exclude. This is really important, and I'll get to this later on in the presentation. The last thing that we will say and be very transparent about is the model algorithm. We're not, faking out that we're using some crazy neural net. In a lot of cases, we're using random forest, and we're transparent about that. We will tell you exactly how we built this model. So we have learned over time, again, Swiss Army knife bad, small contained example good. So we have learned that you need to gain trust, obviously, from your end consumer, so from a trader. So starting with something that doesn't feel overly complex has worked out really well for us. So we have used something as simple as feature importance, right, an introduction to ML to get traders on our side. So we use feature importance as a way to do attribution of trading cost. What's the biggest driver to this predictor, which in our case is trading cost? Was it volatility? Was it that the order size you were trading was really big? In a lot of cases, the output of this, right, you get those really nice charts that you can show the trader. The output of this is intuitive to the trader. I've now started to peel back that black box of my model. They're like, oh, yeah, I get this. This makes sense. This feels good. So they're now starting to get on board, and in many cases, though, we're then able to show the value of machine learning by pointing out an important feature that maybe they hadn't thought of. A really good example of this is for one of my clients when I ran an ML feature importance analysis, time of day bubbled up. Purely if they got an order at 10 a.m. or they got an order at 2 p.m., that drove their cost outcome. The models are supposed to be a random walk, right? So that's a little kind of counterintuitive that if I got it at different times in the day, I would see different cost outcomes, but that was the case for them. And it was surprising to both of us, but the data backed it up once we looked into it. So what you're seeing on the screen here is a live external PowerPoint that we show as part of our Machine Learning Monday sessions. So since January, we've been holding these public calls on the second Monday of every month where we walk through different experiments that we've been running in the ML space. These started out originally just for us to kind of be like, we're experimenting, we're having fun, why don't you come join us? But it's really helped us gain a community with our customers. We presented an issue on one of these calls back in August, and within 5 minutes of that call ending, I had 3 different emails from clients being like, did you try this? How about this? Think about this. That's community, and that's absolutely fantastic and unexpected. So in these ML Monday sessions, depending on our audience, this we knew was earlier on in the process. We knew we had some non-ML practitioners. We actually go step by step through what our ML process looks like. So we start with our data set, right? We had to obtain and clean our data. We clearly specified 2 data issues we ran into. So one of the key features that we wanted was a intraday volatility value, and that was basically not populated in our data set, so we had to exclude it. Another issue we had is at the point in time we were running this analysis, we only had a quarter of data accessible through our internal APIs. We really wanted 5 quarters of data because we wanted to have this model cover different market condition regimes. So we state that very clearly. We then go into what feels like overkill, right, to probably many of us, but for those in your audience that are less experienced, this starts to take that insecurity away from what ML is. We say, hey, the next thing we do is we separate our training and testing data sets. We select inputs into our models, and I'll show you how we kind of publish our features, what that looks like on the next slide. We clearly have to train a model. We will even mention the actual version, the library that we used. Depending on our audience, we might go into more detail, we might not, we might keep it this high level. This is all 100% in the goal of transparency and gaining trust with our end customers. Okay, so this is what a feature selection slide will look like for us for any of our published models. We do want these to be as human readable as possible. I know the previous speaker was saying that, for model documentation, they have 250 pages, and that felt right. My traders have a lower attention span, right, in a lot of cases, and if I gave them 250 pages, they would probably fire me. So we keep things as succinct and easy as possible. So we always start in the upper left-hand corner with our feature selection criteria. So for this specific use case, we said We wanted to pick features that capture order difficulty, and we want to exclude anything that's not known prior to the trade. Very clear. We then always break down our features into 3 different groups. Categorical, see things like country, side, and sector. Numerical, things like spread, volatility, and market cap, and then what was excluded. All of our traders who attended this call, they knew all of these features. We're again, right, pulling that black box back for them. They're like, oh yeah, of course you would include side, and oh well duh, volatility is really important, of course you would put that in your model. For our excluded feature, order momentum, we clearly state that this was just too endogenous for the label that we were predicting, so we excluded it. You might have thought that you should have included in this model, but we decided to exclude it, and this is why. So the last slide you're seeing here is we will write up explanations as basic as this. We knew, again, our audience was newer to ML. A lot of people who are newer to ML are fearful of asking questions that they feel like are obvious, right? The amount of time that I spend on Google on a daily basis being like, what is this in machine learning? There is just too much in machine learning for you to know. This is not Roman history. You can't memorize it. It's constantly changing. It's constantly evolving. So we're all constantly learning, and we need to get comfortable with asking questions. But for a lot of our clients to start, they don't feel comfortable. So we say to them, we explain, on that process slide, we said we're going to run something called permutation importance. And now I'm going to tell you what that actually is. So we first start with feature importance, because that's the basis of permutation importance. And we say this is an output that measures the relative importance of each feature on predicting the expected outcome, which in our case is transaction cost. We try to write it this plainly. I don't want to disparage my mother, who is a very intelligent woman, but she could read this and kind of get, right, what my job is. She could finally possibly explain to my grandmother what I do for work based on this slide. So we try to keep it as simple, as straightforward as possible. We do also mention, though, some cons, right? You can only run this against our training data set. For permutation importance, though, it's just the process of shuffling it. And this can be run against our testing data set, and it can be used to identify highly correlated features. Utter, absolute transparency. It's overkill, I know, but it's helped us be successful in the ML space. Okay, so let's move on to a little more exciting example than random forest feature importance. I'm sure you didn't come here to just hear about that. So I mentioned that we have had failures and that we have tried the Swiss Army knife of ML models. So we have tried to build a model across all of our data set to basically predict outcomes. We've got this fantastically large data set that essentially we're the only people in the industry that have it. So that's what makes our process so unique. It's not our approach, it's our data set. So it makes sense that maybe I can build this fantastical Swiss Army knife model by running it off of this really big data set, and I'm going to predict absolutely everything in the entire universe. We've tried that. We failed. The reason that we failed is that when we looked at the specific examples in our data set, what we have is you'll look at 2 trades. So say we look in our data set from yesterday and we look at 2 trades in Twitter. They're traded for the exact same quantity, so there are 1,000 shares, and they were traded at 10 a.m. yesterday morning. Great, those are my model inputs. When we look at the labels, my model outcome, which in this case we're trying to predict what the expected transaction cost is, I see 2 very different outcomes, right? So I'm telling the model, hey, here's 2 inputs, learn off of this, but then I'm saying, psych, 2 different labels, like, good luck figuring it out. And the reason for that is, as good as our data set is, we don't capture human intention, human behavior in our data set. So for that first client, they had a portfolio manager sitting beside them saying, get this done, trade this now, I want this stock in my portfolio, trade, 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 buy, 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 right? And they have a really bad cost outcome, but that's what the PM wanted, so that's what they did. For our second example, the trader had full discretion. They traded it over the full day. They had a really good, small implementation shortfall. Andre Perold would have been really excited. But you can see why this is a problem in our data. So going back to what we said has been successful from an approach perspective, small, finite goals. So we reduced our prediction space. We reduced it to a very specific type of trade, which in this case is an algo wheel. So I know throwing out a ton of different trading industry terms. An algo wheel is a randomized experiment where you route orders to different brokers in order to evaluate how they perform. It builds a really nice, non-human biased data set, and when we looked at it for machine learning, it's the perfect training data set. I no longer have that noise. I've got a really big, robust data set that is perfect for me to predict my cost outcome. So again, all these slides were from live external examples. You might call me lazy as a presenter, because yes, I did just basically go back to past presentations and chuck them in here, but hopefully my story is taking you along. So we started with our input data. We clearly say we have 6 months of algo wheel flow, 4 months we used for training, 2 months we used for testing. We did make very active data exclusions, so we had some tags missing for what the actual strategy of the trade was, and we felt that was important enough that we kicked those out. And then we just made 2 pure data quality calls, so orders that were really large. This is an arbitrary threshold. It could have been orders greater than 12% MDV, orders greater than 8% MDV. This is the call that we made based on our experience and by looking at the distribution of the data, but we're putting it out there. We're putting it out there for people to challenge and say, why 10%? That feels too small, or holy cow, that's too big. We also then excluded outlier outcomes. On the left, because we have a mixed audience, we use the visual, right? I'm a big proponent of data viz. I've drank the data viz Kool-Aid. So a chart is a really good way for us to say, yes, we do have dark trading represented in our universe, but it's really itty-bitty compared to implementation shortfall. So when it comes to predicting dark trading outcomes, probably not going to be as good at it. Full transparency. This slide looks familiar, right? We do copy, not only do we copy from past presentations, we copy presentation to presentation. So we have clearly our feature of selection goal. We have our features broken out into categorical, numerical, and excluded. Because this model was a lot more complex, we actually split our feature importance process into 2 phases. So the first thing we did is we just wanted to work with the features we had. We wanted to get something to market in front of traders as quickly as possible. And then the second thing we said, clearly we're going to go back. We have other ideas for features. We want to experiment with this. The 2 people who joined me from my firm are actually the people who are actively experimenting with this. So this is still an ongoing process for us. And we do tell that to clients, right? There is no final model. We're going to continue to experiment. We're going to continue to play. We're going to continue to test. And if we make a change, you know us, we're going to come back and be transparent about that. But we can promise you we're going to keep looking at this. So for all of our models, before we go into production, we have what's called a peer review process. This has become a bit contentious based on the model. So all of our models are built with teams. So the team of the model builders gets invited. And then let's say 4 to 8 non-model builders who are subject model experts get invited to this kind of peer review. The goal of the peer review, what everyone is challenged to do, is ask questions, challenge every single assumption that we have going on. So for this model specifically, duration and participation rate grossly improved our accuracy, but we just couldn't get over how endogenous they were with our end label. So we did decide to exclude them, and this was a way that we could show our traders that, yes, we did think about these as features, we actively thought about them, but we kicked them out. Visual representation of model output. As someone who works in ML all the time, I still feel like model accuracy metrics are sometimes just overcomplicated, right? A visual, it's worth 1,000 words here. So our, in this case, prediction is that black outline. Our observations are the green data. Our traders can get comfortable with the fact that when it's a difficult order, so we skew negative, so when it's a difficult order, don't worry. We're going to give you enough handicap, but you should, in a lot of cases, actually be able to outperform that. How am I doing on time? Okay, great. How many? Fantastic. Okay. So other models that we've experimented and deployed this year are clustering to populate partially tagged data. This is a personal favorite of mine. My only experience before with semi-supervised learning was hand labeling for NLP, not my favorite experience. This, though, semi-supervised learning off of numeric data, it's fun. And so we publish a report every quarter where we basically say this is the average commission rate that the buy side pays to their brokers to trade for them. This has always been a blended rate for us. It includes the execution and the research tack on. We've wanted to split these two things out in the past, but the data's only about 20% tagged for us. So we've tried to draw kind of lines in the sand, but it was never perfect. Insert semi-supervised learning, we've had great outcomes, and since this year, we've actually started publishing this report with the execution-only rate. Trading strategy recommendation engine. This is probably as close as we are going to get to that Swiss Army knife single output model. We have probably experimented with this type of model where I actually tell you how to trade 5 or 6 times over the last 10 years. We have yet to publish this model, so yes, we failed 5 or 6 times. Based on all of our failures and our experience over the last 18 months, we've actually had some really great breakthroughs, and we're planning to launch this model in 2023. We do ML on other asset classes, so not just equity, not just stocks. We do it on FX. This is a great example of that very small, finite use case. We can predict with very good confidence which bank is going to provide the best rate in an FX currency. Not a lot of our clients trade a lot of FX, or in this case, the type of trading that we're looking at is RFQs. That could be a small subset for them. But for this specific use case, we can build a very successful model, gain the trust, get them on board with ML, and hopefully at some point combine that with a bigger model. We have also experimented with Twitter sentiment analysis. So if you followed any of the meme stocks, right, Reddit, all the big thing that you can apparently go on Reddit and learn something about stock trading and become a millionaire overnight. So we were like, let's go look at Twitter. So I'm not a Twitter user. My first experience really with Twitter was this summer when we started pulling in tweets through an API with, by the way, my 20-year-old intern. And holy cow, is some of that language really visceral. So we struggled quite a bit to kind of come up with anything that wasn't really, really negative. So this was a good NLP experiment. It was a really fun intern project, but this I would definitely chalk up to our failure column. So back to the challenges. I mentioned that there's definitely challenges in adoption of ML in the trading analytics space, but on the back of this year, on the back of the amount of clients who've actually attended our ML Monday sessions, on the back of our conversations with clients, I'm feeling really confident that 2023 is finally our year. I know we keep saying that about COVID, right? Next year's finally the year, we're free, but I'm telling you, 2023 is going to be the year of ML adoption in trading analytics. We've gained the trust of our end consumers. We're intentionally building transparent models. We're starting to plug the holes in our data set, our skill set, right? All this experimentation, all this failure, we're getting better. And we got those environments set up thanks to some tech resources. Thank you, everyone. I'm happy to take, I don't know how much time I have for questions, but I'm happy to take them. I know, this was a very kind of niche-y topic. It wasn't as general. Yes, sir.
So we talked earlier about how to build trust, and you were talking about feature importance. How do you work with this non-machine learning end user that will jump to the causal conclusion of the if this then that, and setting expectations on how to use feature importance in the right way?
Well, that's a very good question. So you do have to channel that energy, right? And in many cases for us, that energy, even if maybe they jump too far, too much to a conclusion, right? Oh my God, I've solved everything, that's actually been okay. So, we will add caveats to things. We will add, hey, let's review this again. But I think in our experience, having the energy, even if maybe they go a little too far, where in your head you're like, is actually okay, because they're now on board with your process. And they themselves at some point are gonna probably be like, whoa, I made a big assumption there, I'm feeling a little silly, but thankfully no one called me out on it, so I actually feel okay about it. So it is a very, you know, I'm in 100% client-facing business, so I have to balance that, let me give you information with, and still make you feel like you're smart about what I'm talking about. Yeah?
So kind of building off that question, when they want to understand sort of directionality as well as magnitude of a specific feature on the predictor, are there any other tools that you use besides just feature importance, which shows just relative importance?
Vesna, would you like to speak to what your favorite ML library is? We are big SHAP fans. We, in this case, we didn't talk about it, but we are massive SHAP fans.
Reception of SHAP been with the non-technical audience?
It does take a little bit more. So usually, actually, and one of Vesna, so Vesna actually put together all those slides on the second one that I stole. So I trimmed those down. So what we did in that presentation is we started with feature importance, which is a very straightforward graph. We explain what feature importance is. We then show permutation importance, and we explain what that is, and then we show SHAP. So we show all three and work up to it, and that also confirms, right? You want to see consistency amongst those. If you don't, you might have a problem. So we build up to that knowledge. I do agree SHAP is probably a little harder to interpret than something like feature importance, which is just that really basic bar chart.